Welcome back. Now, Noel hardly needs any introduction from us, really. He's led the development of digital amateur TV receive capabilities within the UK and has built DATV receivers from all bands from 50 megs to 76 gigs. They clearly work well, as he won this year's IARU Region 1 Amateur Television Contest using his home-built equipment. So please feel free to ask questions and make comments on Zoom and BATC Streamer for the last time to Noel, and I'll read those questions to him later. And please include your first name and your call sign if you've got one at the beginning of your message. So now Noel joins us to discuss how you can optimize the gain and sensitivity of both DVB-S, S2 and DVB-T receivers, which both have different requirements. Welcome back, Noel.
Thank you, David, and good afternoon, everybody. Hopefully this isn't too much of the graveyard session. But I must admit that that previous session by Ian and Peter was absolutely tremendous. So yeah, really pleased that we could bring that. Right. Well, what I'm actually going to be talking about today is not just gain, but as I wrote this presentation, which I finished about an hour ago, it really morphed into talking a bit more about DATV receive systems rather than just the gain as such. So I've entitled it DATV receive systems, and the approach I've tried to take is very much a practical approach. We are pretty unique in the ATV world. The microwaves do some of it, but we build our own. Well, we build our own systems, but we build our own receive systems, and there's certainly no black boxes here. If you walk into Martin Lynch and ask him for any of the stuff that's been talked about today, you get pretty short thrift. But we do use pre-built components, but what this means is really that the system design around how we put all of these bits together is important. We've got the tools to get it right, but we just need to understand a few parameters to really optimize our receivers. This is very much a practical guide. There's hardly any theory. It's not really a purist approach, but it does work for me. It doesn't cover satellite LNBs for QO100, as you just put one of those up and point it in the satellite and it works. So the topics that I will be covering are three important receive parameters, those being noise figure, gain and dynamic range, and filtering. And they're three things that we really need to consider. I'll then be looking at how we put those together into a practical DATV receive system. I'll mention a couple of other things such as the TXRX sequencers, masthead preamp boxes, and microwave transverters. And as David said, the June IARU contest, I was very privileged to win that, and that's actually my portable setup on all the bands that I took out. It's actually on Dunkery Beacon, and you'll see there's one or two boxes hanging on the mast there, which are masthead preamps. So let's talk about the first of these important parameters that we need to understand. And that one is noise figure, or receiver noise figure. And trying to keep it very simple and in simple man's terms, all electrical circuits basically make their own noise. E.g., if you turn an audio amplifier up high without any input, you will hear hiss. And those effects become more and more dominant above 1 gigahertz, where silicon and semiconductors really have noise. And this internal noise, it's generated internally in our circuits, stops us from hearing weak signals. And so a good system design really will keep the effect of this noise to a minimum. And when we're talking about it in terms of preamplifiers or other amplifiers, we measure it in dB. And that really is a difference between the input noise ratio and the output noise ratio. And so a lower the number, the better it will be. I tried to try to find a better description of that. And about the best one I found on the web was this one, which came from the globalspec.com website. And they said that the signal power is higher at a amplifier's output than that of the signal before the entering the amplifier. However, because the amplifier adds noise, the noise flow at the output is raised significantly higher. Therefore, the signal to noise ratio at the output is less than that of the input. And I think that little diagram shows what's going on, and the noise floor is raised. It also looks to me that diagram that there's been a bit of compression on the actual wanted signal as well. But it's basically trying to keep this dreaded noise to a minimum. And so how do we do that in a practical sense? And the golden rule to understand really is that the first stage in any system is crucial and sets the system noise figure. And you will never recover from a poor noise figure. If you don't get it right at the front end, you could never recover that. And any loss that you put in front of your first preamp will affect your ability to receive weak signals. And loss is generated by, is inherent in things like the coax cables you use, connectors. I'll talk a little bit more about that. In fact, I'll probably talk a little bit more about most of these things. Relays, filters. You'll notice there's two asterisks against filters. Water in the coax. Yep, that will affect your system noise figure. And so the golden rule is to always try and get your preamp at masthead, particularly on the higher bands. And what the picture there shows is 23 SEMS, 5.6 gigs, and actually 70 SEMS, but the first two have got boxes screwed right up against the aerial because it's crucial to get your preamp onto the aerial to try and keep that first stage noise down as little as possible. So when we say that, we then sort of have to try and understand what is a good noise figure. Well, and I bow to Ian SEK on the, I haven't actually used his words, but the essence, he did a very good talk at one of the EME conferences. And what has become to be understood is that, you know, what is a good noise figure and what is a desirable noise figure really depends on what you're doing. Leave aside EME or Earth Moon Earth, where every 0.1 of a dB counts. For above 1 gigahertz, aim for a 1 dB system noise figure. Probably isn't a bad place to be going. And below 1 gigahertz, it's really not worth the effort. And, you know, a 1.5 dB system noise figure for the types of things we're doing on 70 SEMS and 2 meters is probably adequate. And even on those bands, it becomes very desirable to put the preamp even before that, put the filter before the first preamp. Even though it's inflicting loss on your system, you will benefit from cleaning up and removing interference. And we'll talk a little bit more about that later. Noise figure is currently very difficult. It's very expensive to measure. You need a component called a noise figure head, which we talked about earlier on this morning. And then you probably need a big shiny gray box, similar to that which I've got under the bench here, which is an HP noise meter. But hopefully Dave is going to change that with his work that he's doing on the Portsdown project. So because it's so difficult to measure, the best rule of thumb you can have, if you haven't got the ability to measure it, is to use known components. So when you're building a masthead box, use a good preamp, and then you can measure the filter and the relay and the coax losses that you're putting in front of it to try and minimize it. And so really what I'm saying here can be summed up in these two slides, that you're going to have loss in your system, but where you put the loss is really critical. And this slide shows really that, you know, any loss in front of the preamp is really, really nasty. So don't do that. Just keep your losses in front of your first preamp to a minimum, and put any loss, such as a long feeder from your antenna, keep behind the first preamp. You can always put another amplifier or gain block in at the bottom of the coax to compensate for the loss. Doing that will not affect the noise figure and the performance of your receiver. So noise figure is important, but also so is system gain. And this is where I give another plug to Ian. Gain is needed in the system to overcome losses after the preamp. So any filters that you put in after the first preamplifier, any coax, any splitters or switches need to be compensated for, but too much gain can be a problem, particularly when you're building for narrowband systems. It's not so much of a problem in DATV systems because the actual devices we use to receive the signals, i.e. the tuners, aren't particularly sensitive in themselves. But if you're looking at using a common system between narrowband and DATV, you really need to be very careful, careful system design to avoid overload. And I think twice I give Ian a plug here. He has done some great work on understanding the system gain needed in narrowband systems, and has built the DG8 2-meter preamp, which noticeably has relays and filters before the device, because Ian quite rightly says that, you know, filtering is better than noise figure on 2 meters. So have a look at Ian's website. Just remember IFW Tech and Google that after the session. So I mentioned that, you know, DATV is slightly different from narrowband systems when it comes to system gain. So how much gain should we be putting into our systems? Well, it actually depends. I've said already that narrowband transceivers don't need much because they are inherently more sensitive than the tuners we're using. But we've got a bit of a dilemma as DATV people. We've got 2 tuners which have got different requirements now. So the Nooker requires a bit more gain. And that's because the Nooker is designed around a terrestrial tuner from Serret. And a terrestrial tuner is designed to be plugged into an antenna. So actually, the Serret 4762, which is the tuner it uses, isn't too bad. I think it's got a noise figure around 8 dB, which isn't too bad. And I've proven here that actually you can put too much gain in front of the Nooker tuner. On the other hand, the mini tuner hardware, which uses the Serret 4473, is deaf as a post, basically. And that's because it was designed as a satellite tuner to work behind an LMB, the piece of electronics up on your dish, which has got circa 55 dB of gain. And because of that, there is no amplifier on the mini tuner PCB. There is a small amplifier inside the Serret tuner, but even so, it likes a lot of gain. So how do you work out what is enough gain? Well, luckily for us, both the Portsound and the mini tuner software can help us get those balances right. So looking specifically at the 4473, which is the mini tuner, Dave has done a lot of work on this, and there's a page on the wiki, which is called Mini Tuner Power Level Indication, of which I have blatantly ripped off this slide. And so what Dave says is at low input levels, i.e. if you're not got enough gain of it, The 4473 will run at maximum gain, and this will impair its performance and lead to a lower MER and failure to decode. And the sweet spot for the 4473 is when you're running mini tuner or when you're running ports down. Both of those give an indication of RF level in minus dBs. You need to be between minus 70 and minus 27 to provide optimum decoding performance. And so you need lots of gain in front of a mini tuner. And how we get that gain, I will come on and explore shortly. But the difference is we've got the problem when we're building a system that you've got to count for all of these differences in gain. So having established that noise figure and gain are important things when you're designing a DATV receiver, surely that's it. You know, that would be good. You'd get a very nice system to work on the bench if you got all of that right. But there's one other gotcha, and this is a big gotcha. People don't believe that you need to put receivers in filters. And I can tell you from personal experience that we do. So the system that we've described may work well on the bench, but it won't work on the air. And that's because we are not alone. There are lots of horrible other people using the spectrum, and there are many interference sources. One of the problems is that these days, because we're running digital and because they're running digital, any interference really just appears as white noise. And so the only effect you see is that the receiver just doesn't work as well. You don't see horizontal bands running across the screen anymore. And this interference can come from broadcast and cell sites. It can be on adjacent channels, near channels. It can be other people on the 2 meter band. I think Dave demonstrated the Lime viewer on 2 meters where he had, or 70 sems, where he had a large repeater running to fairly close to his received signal. One of the things that's been a gotcha for some people is on 23 sems, where we tried to receive 1296. They've discovered that there's a Freeview transmitter on half that frequency, and Freeview times 2 at 600 megs comes out at 1296. And so you put a filter in front of your preamp and stops it. And my message would be always run a filter on 70 sems. Filters will reduce most of the crud. You may, when you've got a very specific interference, you may have to run a notch filter. And, you know, sacrifice system noise figure for better filtering is very much the message. And so what's that funny picture there? Well, that funny picture there was when I learned a hard lesson. So on the left, we have a picture of, I think that was SDR Sharp, looking at 146 megs. And this was on the Isle of Wight. And we went out to the portable on the Isle of Wight, and we worked Sean GW8VPG, or we tried to work Sean GW8VPG, who was over on Bloringe in South Wales. And this was on 146 megs. And we were looking to try and do 185K, which would have been a record for 146 megs at the time. The picture on the left is the received spectrum without a bandpass filter. The picture on the right is exactly the same system with a bandpass filter. I think, if I remember rightly, and I can't check because I'm not viewing the chat, but I'm pretty sure the system on the left was mine. The system on the right was Dave GKQ's system. And we worked out the only difference was bandpass filtering. So the message very much is, you know, you may not realize why you need it. And when you test it on the bench, it works fine. But when you get out into the big wide world, particularly on a hilltop, you'll find that there are lots of nasty stuff out there, and you really need to put filters in your receiver. So they're the three big parameters that you need to worry about. So how do we go about designing a system for DATV? Well, I think these are a few go through major points that I would stress. So masthead low noise preamps on all bands above 1 gig. Maybe, yeah, I think that is still correct. Good coax with preamps in the shack below 1 gig. Now, note what I said there, that good coax. If you're going to put the preamp in the shack, for goodness sake, run good coax. Don't try and get away with RG213 on 23 SEMs or whatever. It's always interesting to find out what the loss of coax is, and the easiest way is to put your 10 or 15 watt transmitter on 1.3 or 2.3 into a length of the coax, and you'll be amazed after 5 minutes you can feel it getting warm. Bandpass filtering on all bands, whether the preamps are in the shack or in the mast. Optional band switching. Why do I need that? Because plug-in sockets are a nightmare. You need some additional gain to overcome switch and filter losses. And you can put in a signal splitter to feed mini tuner and your Nooker NIMS, plus maybe the band viewer. Aim for the correct level in mini tuner and put attenuators in the Nooker and SDR feeds. It's probably the way to do it. And use a transmit receive sequencer to avoid smoke coming out of your preamp. And if you look at that in a it's kind of a block diagram, you'll see over on the left hand side, you've got the two bands which are below 1 gigahertz, and there I've put coax with the first amplifiers in the shack. The shack wall being represented by the dotted blue line. Then you need filters and some gain into some form of switch. You can either use the BATC 8-way switch or a relay into a splitter, and then from there you feed the various receivers. But one of the important things on this slide is you'll note that Nooker is fed by a 10 dB at least attenuator. Above 1 gigahertz, put the preamp up at the mast, long piece of coax. If you need a bit more gain, put it in at that time and put it into the relay. And on microwaves, you can do exactly the same with your transverter. Your transverter just looks like another receiver, which happens to be on probably 144 or 432 megahertz. It just goes into the block in the same way. So that's the outline. Actually, I guess that's the outline of my system. So practical thoughts. Preamps. There's a bit of a rule with preamps and relays, really. Buy the best you can afford. There's commercial solutions, DB6NT and G4DDK. Sam does some absolutely excellent preamps for 23 SEMs and 13 SEMs. Not cheap, but you get what you pay for, and same with DB6NT. You can use eBay and AliExpress stuff with caution. Or on the lower bands, all I use is some mimics, the PGA 103 or SPF 4531, or one of those. Sam did a PCB, which you can see there. And just build your own, roll your own, put it in a box, and of course, whatever the solution, whichever you're going to be using, surround it with filters. Most of us use second-hand surplus filters. There's always a mad dive at the rallies to if there's any filters available. They're fine. The Chinese stuff is fine that you get on eBay and the AliExpress, but always check the loss and, if possible, the shape using a mini VNA before you put it in the system. And yes, it's all very well and fine to do the final tweak within the system, but try and align it first on a signal generator. The port down has got signal generator capabilities, or the mini VNA, use something like that. You've now got an amazing array of test equipment at your fingertips for very little cost, which we didn't have 10 years ago. So this shouldn't be too challenging for anybody. And the coax you put after your masthead preamp is not too critical. But there again, always measure the loss. It's interesting. There was a comment Rob M0DTS made on the BATC net before the contest, because he always does something that I do as well, which is before we go out on any of the portable contests, the big ones, we measure our coax loss, because coax does go funny. Connectors fall off. It gets damaged when you wind it up. So always double check. More practical things. Transmit receive relays, buy the best you can find. Surplus is fine. When you get up to the higher bands, it's often the only option. I'm afraid I'm not going to give Agilent or anybody the money for a brand new one. Check the spec, and guess what? Measure the loss. And after the preamp, you can actually use satellite coax. Satellite coax isn't bad after the preamp. I'm not sure I'd want to use it on transmit. The only problem with satellite coax is it probably drags you into needing to use F-type connectors, more of which I will talk about later. So in the shack, band switching, far better than swapping plugs, particularly if you go out portable. Use several of us use the BATC 8-way switch. You have to turn it round and remove the amplifier that's in there, because it's the wrong way round. But that works very, very well, and I use one of those on receive. Or you can use the multipole SMA relays that you can get. And in the shack, where it's not going to have any mechanical vibration, it's okay to use satellite line amplifiers and splitters to feed multiple receivers. Again, the only downside is it does force you down the F-type route. But because you've set your noise figure at the masthead, it's fine to use them down there. So, you can feed your line band viewer with a satellite splitter. But don't forget to put the attenuator in before you go into the nooker. Right. We have got a little bit of a problem. We have to get on one or two of the bands, you still have to use frequency converters. So the satellite tuner that we use, the 4473, doesn't cover 29, 50, and 70 megahertz. So you have to use an up converter to get it to a frequency that it does work on. And Mike MJW designed a board which is in the BATC shop. And the OFDM tuner, the 4762, doesn't cover above a gig. And so it won't cover 23 centimeters. Most of the other bands above there, I'll talk about in a moment, and we tend to use transverters. So we need to receive the I frequency. Really, we're only missing 23 sems on the OFDM. Here's the slide about connectors. Don't use F-types unless you have to, and particularly don't use them in situations where you're swapping them or you're doing portable work. The cheap and nasty ones particularly literally just fall off. BNCs are great. I use BNCs. I know some people aren't that keen on them. Beware of the crimp ones. They can fall apart. I particularly try and only use the ones with what is the ferrule, where they're put together with the sleeve pushed up inside the coax. You can get a good mechanical grip on those. But BNCs are fine. SMAs are great, particularly at the higher frequencies, but they're a nightmare because they tend to bind. They've got quite a fine thread on them. And I've heard, I think it was Colin, KLB, had problems with them, and they tend to bind. And they're not really the best. They're a great connector, but N types are good, and the same applies with N types. They're particularly if you get the precision N types, they've got a very fine thread in them, and they will bind. And two bewares. Beware shiny Chinese adapters. Yes, we all have to use adapters, I know, but be very cautious about shiny Chinese adapters. Measure them before you use them, and beware they don't fall apart. I've had them where the pins just come out of the middle. Actually couldn't bring myself to type the name of the last connector that we could use, so don't even think about it. I have got a 2-meter beam with one of those on it, and the first thing I put on is a reasonable quality adapter to N-type. Enough said. One slide on masthead box design. Use a good changeover relay. Oh yes, we've said that. And wire it so it is the normally closed or normally on is on the transmit line. The reason for that is you can then put volts into the box, which powers the preamp and that relay. So therefore your system switches, you just power up the coax into the receiver. And when you go on to receive, you get power and it switches the relay over as well. Now here's an interesting little trick. Leave a vent hole in the bottom and dangle a piece of string out of it. Yes, it does work. It will, first of all, the vent hole will ensure that any moisture does try and run out, but of course you can never drill the hole in the bottom of the box, can you? So it collects in the other corner to where you drilled the hole. Dangle a piece of string out of it, and I forget the technical term. Anyway, basically the wind dries the string, so the string then draws the damp or any wet out of it, and that does work. My 70 Sems preamp box here at home has got one, and it's as dry as a bone in there. One quick comment on coax: use fantastic coax between the antenna and your masthead box, because that's where you get your loss that you can't get rid of. Use good coax on transmit, otherwise you'll lose too much on transmit power. And use okay coax on receive. It doesn't have to be great. I actually use IG213 on receive with BNC connectors on. Works well. One slide on a transmit receive sequencer. Without a sequencer, there is a risk that the TX will still be on when you power up the preamp. Oh no, that slide is totally incorrect. Yes, there's still a risk that the preamp will still be on when you power up the PA. And the result will be smoke from your preamp. And if you can see that diagram, really the sequence that we want is when you press the PTT, we'd really like the antenna to go on. So go from receive to transmit. You really want the antenna relay to go over and the receive to go off. Then you enable the PA and you produce RF, and you want exactly the opposite in the other direction. So when you let go of the PTT, you want the transmitter to shut down. Then after that, the preamp and the masthead relay goes over. Plenty of designs available, even down to just 2 relays. There's a good design I use, which just uses 2 relays. Ask Google and drive that from the ports down PTT output. And if you put it before the band steering, if you've got one of the band steering boards, if you put it in between there, you will get steering on all of your bands. Okay, just a couple more slides. One slide on microwave receivers. Most stations who are on the microwaves use transverters or LMBs. Be a bit careful if you're using sorry, no, that's wrong. So basically the transverter will do all of the nasty work for you. It should take care of the LNA and the bandpass filtering. And they have an IF of 144, so they can go straight into your receive system, and it is treated just as another input. But just be cautious, because transverters are designed for use on narrowband transceivers, so they're low on gain. So you do need additional gain in the shack box, really, just to boost that up. Be careful if you're using a satellite LNB for 10 gigahertz or for QO100, and you want to feed it into the system we described. They've got a very high noise level out, even right down at 2 meters, and particularly at 1296. So switch the DC off when you're not using. Otherwise, you'll find if the isolation of your switch isn't particularly good, you'll get noise on the band, which comes out of the LNB. So make sure you switch the LNB off if you're using it into some form of selector. So there we go. Conclusions. Low noise masthead preamp, preferably a masthead. Don't forget, cables have big losses. They're not loss free. Enable enough gain to overcome the cable and system losses. And the first stage is the critical stage. You never can get that back. So your next steps really are to go and read Ian's papers and use his spreadsheet that he's put on his website to calculate the amount of system gain you need. IFW Tech, just remember that. Measure all your coax, measure your filters, and then measure your coax and measure your filters again, put it all together and work the DX. And that's my best DX ever on 77s there. F1, FY, I think that was about 700 kilometers. So there we go. That pretty much wraps it up.
Noel, I can't believe it. 4 o'clock and 2 seconds. That's pretty good. You caught up a lot. Thank you very much. Not that we're set by a particular hard rock time. Anyway, thank you very much for that. Really a sort of, I suppose, an overview of some of the ATV things, some of the basic stuff that some people may not know. We've got one question so far. Can I just start by asking another one? I'm aware that some people may be interested in TV, amateur TV, but really not know where to start. And some of the stuff that we've covered today, let's face it, though it's really interesting, it's quite deep. Yep. So if someone was just interested in this television stuff, what would be the first thing that you think they should invest in to get started?
So we do recognise this as a problem. We all know too much, and there's far too much information flying around. If I can just be bold and do this. It's all right, Tammy, I know what I'm doing. If I go to the wiki, there is a page which is getting started. Now, we put a bit of effort into this, and it's still not right, but we are trying to give a roadmap forward. And you know, so we've entitled it really easy: receiving digital TV, transmit. And so the answer to your question, actually, David, is the 5.6 gig FM stuff, which you will remember because we took it up to East Runton.
And there's another, a wonderful day that was, wasn't it?
There's a whole page on how to get going, what to buy, how to put it together as a system. And that really is the easiest and cheapest way still to get on TV. Now, Portstown has made great strides, and we've generally made great strides in making digital more accessible.
Can we just tell people quickly, sorry, Noel, that the 5.8 gigs things, they're often modified sort of first-person view type equipment that's made very cheaply for the drone market and radio-controlled planes and that sort of thing, isn't it?
That's correct. That's correct, yes.
So a very low cost, easy way to get plugged and played.
Yeah. So, you know, and we have made, Portstown makes transmitting digital much more accessible. And if you would ask me what to do on receive, I'd say get a ride. You know, it's so easy just to build that PCB and put it in with the Pi 4, and you've basically got yourself a system. And of course, these days, the other great thing is that there is always DATV signals around on the satellite, so there is something to watch. But the BATC forum is a great place to answer questions. We won't bite your head off. There's a lot of friendly people there, and we do realise that it's we're trying, but we've got more work to do on making it more accessible.
Oh, that's good. Thank you very much for that impromptu answer to that. I think that's something, though, that we need to bear in mind, that some people maybe just making a start in this. So I've only got one question, which I shall read in a moment. So if you have a question for Noel, I guess about almost any aspect of anything to do with the club, because he's the secretary of the club, as you know, then please enter it now, either on BATC Stream or on Zoom. Otherwise, we'll be wrapping up the final session. So the question came from John G8PF and says, read the graph of the 4-stage sequencer. What sort of time delay between each step would you be aiming for?
I think that's a bit subjective. I like to be able to definitely hear and see the difference between the LEDs. So I suppose because we're not going for quick fire QSOs, you know, we're not in a CW contest. I guess I'm up at around the half a second mark, if not more. You know, err on the side of safety, really. And most of these sequences do have variable delays. But yeah, because if you're like me, you're probably using mechanical relays, so there is a finite time for those to change over. So yeah, I'd aim for sort of between half a second and a second.
Okay, thanks, Noel. Well, we haven't had any other questions. I think it's probably because you covered things so well, and also probably people's minds are quite blown now after quite a day of things here at the convention. So, Noel, thank you very much for that presentation.
Okay.